Hey there, this is Dr. Rishi from the Learners Academy, and today we are going to go ahead and talk about irrational numbers. In the previous video we had talked about rational numbers. Today we have irrational numbers. So effectively irrational numbers are all the numbers that are not rational, meaning they cannot be put in the form of P upon Q. Let's see what all numbers come under this category. However, before going ahead, let's have a small recap of what we've done so far in learning different kind of numbers. So the first kind of number that we studied was natural numbers, 1, 2, 3, 4, 5, 6 till positive infinity, whole numbers, 0, 1, 2, 3, 4, 5, 6 till positive infinity, integers, all the positive numbers, all the negative numbers and 0, and then rational numbers. These are the numbers that are written as P upon Q, where Q is not equal to 0. So all the fractions, all the decimals would be included in these. Now, let's go ahead to the new topic that we have, that is irrational numbers. So what are irrational numbers? Irrational numbers are numbers that cannot be written as rational numbers. So what would they be? First thing that we need to consider are the square roots and cube roots of numbers that are not perfect squares or perfect cubes. They would be listed under rational numbers. Second thing that we have is constants like pi and e. Now you'd say, sir, pi is equal to 22 upon 7. No, pi is not equal to 22 upon 7. 22 upon 7 is a very, very, very close approximation of pi. However, pi is defined as circumference of a circle divided by its diameter. And this is a constant value. It is very close to 22 upon 7. However, it's not actually equal to 22 upon 7. Yet for lower grades, it's not a problem because we are not dealing with that many decimals as such. The third thing that would come under the list of irrational numbers are numbers whose decimal expansion is non-recurring and non-terminating. So it won't recur itself, nor would it terminate. It would keep on going forever. Whenever we associate with numbers, or whenever we deal with numbers, we always plot these numbers on a number line. So is it possible to plot irrational numbers on number line? Yes, absolutely is possible. Now it sounds pretty absurd because these are the numbers that are non-recurring, non-terminating, so they are going on forever. However, we are still able to plot them pretty precisely on a number line. We can do it geometrically, so let us see how we can do it. So in front of you, we have a number line. So I have 0, 1, 2, so on and so forth here. Now how are we going to plot the number root 2 on this particular number line? So let's talk about plotting root 2 on a number line. Now we are going to use our good old Pythagoras theorem to plot this particular number on a number line. Let's see how we would be doing it. So first thing we do is we draw a perpendicular at point 1 such that the length of this perpendicular is equal to 1 unit. So whatever length is here, the same length would be here. Now if you see, we can get a beautiful triangle like this, and I can, if I name this point as O, this point as O, this point as A, and this point as B, you can see that OB square would be equal to OA square plus AB square, where OA is 1 unit and AB is also 1 unit. So I can write easily, I can write OB square is equal to 1 plus 1, that is equal to 2. Therefore, OB will be equal to root 2. So the distance I have is root 2. I can draw an arc keeping my pointer at O and my pencil at B. I can draw an arc like this and I would get root 2 here. Same way I can draw root 3, root 5, root 7. Let's give it a try. So there are two ways to do it. One way is we can draw a perpendicular at this point. Okay, so now we are going to call this point at C. Then at point C, I'm going to draw one more perpendicular whose length should be equal to the length of OA. Now, in this case, what we would get is it would be root 2 square plus 1 square. So now what we would have is, we would have C, let's call this point as D. So we would have, let me try it with a different color. So I have OD, the red color is root 3. So I can say that OD square is equal to OC square plus CD square. So that would be root 2 square plus 1 square. So that would be 2 plus 1. So that is 3. So I can write OD is equal to root of 3. Now, by drawing an arc from here, keeping the pointer at point O, my pencil at point D, I can easily draw an arc like this and get root 3 here. There is one more way of doing this, by drawing the perpendicular at point B. So I draw a perpendicular to line OB at point B. Length of this perpendicular is, let's call this as BE. Length of this perpendicular would be taken as equal to 1 unit, that is OA, and I would end up with getting my OE in the same manner, because the base would be, this side would be root 2 and this side would be 1 unit. So this line OE would again be equal to root 3, exactly like this line. If I keep my pointer at point O and my pencil at point E and I draw an arc, you would see that it would coincide with point D and go to root 3. So this was about drawing irrational numbers on a number line. Now let us go ahead and talk about irrationality of irrational numbers. So basically we are going to prove why these numbers are irrational, or how these numbers are irrational. There is a specific method to prove this. It is called as indirect method of proving. Indirect method logically is pretty simple. We assume our statement to be true, then we prove that our assumption is incorrect, and we end up with proving, or we conclude that since our assumption is incorrect, exactly opposite of it would be true. So let's see how we do it. Now let us prove that the number root 2 is an irrational number. So how would we do it? Now we generally prove it for root 2 and root 3, and then we generally use it everywhere else. So this theorem is there in standard 9th ICSE and state board, and it is in standard 10th for CBSE. So let's see how we prove that root 2 is an irrational number. So we, as discussed earlier, the first thing that we have to do is we have to assume. So let's see what we assume here. The first statement that I write is, let us assume that root 2 is a rational number. Now, since I have assumed that root 2 is a rational number, I can say that root 2 is equal to A upon B, where A and B are co-prime. So I'd write it What do you mean by coprime numbers? Coprime numbers are two numbers which have nothing in common except 1. So it's basically a fraction in its simplest form. So we say that root 2 is a upon b. Now we'll go ahead. So we assumed that root 2 is a rational number. We have to prove that it is irrational, but we have assumed that it is rational. So now we have to prove that our assumption is incorrect, and then we can go ahead and say that it is irrational. So we have root 2 is equal to a upon b. So I can say that therefore a is equal to root 2 multiplied by b, or by squaring both sides we can say that a square is equal to 2b square, where so since a square is equal to 2b square, it would mean that a square is a even number which is divisible by 2, which would mean that if a square is divisible by 2, a should also be divisible by 2. So I can say that therefore a square is divisible by 2, therefore a is divisible by 2. We know that if square of a number is divisible by a particular number, then that number itself would also be divisible by that particular number. Okay, so let us call this number as t. So we say that let a equal to 2t, meaning if I take a, here I have proved that a is divisible by 2. So I say that if I take a and I divide it by 2, I will get a number t, or a is equal to 2t. Now what happens if I square these numbers? I get a square is equal to 4t square. After this I can say that, now this is my first statement telling me that a square is equal to 2b. This is my second statement telling me that a square is equal to 4t square. So I can compare these two statements. Since both of them are equal to a square, I can say that 2b square is equal to 4t square. Therefore b square will be equal to 2t square, which means b square is also an even number and divisible by 2. And if b square is divisible by 2, I can say that b is also divisible by 2. So therefore b square is divisible by 2, therefore b is divisible by 2. Now this is something very important that we need to consider. Here I have proved that a is divisible by 2, here I have proved that b is divisible by 2, which means that both a and b are divisible by 2. However, a and b are coprime. They cannot have a factor other than 1, which means there's something wrong. Which means there's something wrong with our assumption, or simply speaking, our assumption is incorrect. Since our assumption is incorrect, we can say that root 2 is an irrational number. So we can write, therefore a and b both are divisible by 2, and but this contradicts our assumption. Therefore, root 2 is irrational. And there we have it, friends. That is, we have ended up proving that root 2 is an irrational number. Now let us talk about some properties of irrational numbers. The first property that we have is, if we have two irrational numbers, root x and root y, such that if root x is less than root y, then it would imply that x is smaller than y. If root x is greater than root y, then it would imply that x is greater than y, and if root x is equal to root y, it would be possible only under one condition, that is x is equal to y. Now, the second property is, if we have an irrational number a plus b root x and it is equal to another irrational number, that is c plus d root x. So this has both rational and irrational parts, but as a whole this number would be irrational number. Then this is possible if and only if a is equal to c and b is equal to d. It is important to note here that the irrational part in both the numbers is exactly the same. The other things that we need to take into consideration is the negative. The third property we can say is the negative of an irrational number is always a negative number. If we take sum of a rational number and an irrational number, then the number we get is an irrational number, and the product of a non-zero rational number and an irrational number is always irrational. Now let us see what all operations cannot work with irrational numbers the way they worked with rational numbers. So the first is addition. So if I have root 3 plus root 2, then it will not be equal to root 5. It is very important that you keep this in mind. There are a lot of students who make a mistake when they do addition of irrational numbers and rational numbers for that matter. So they would do a mistake by adding these numbers like this. Nor can I subtract it as a root 5 minus root 3 is equal to root 2. I cannot say it because it is not true mathematically. Also, root 5 plus root 5 will not be equal to root 10. Rather, it would be equal to, so if I have root 5 and root 5, I will consider this a single unit. So I can have a root 5 common and I would get, so if I take root 5 common, there would be 1 remaining here plus 1. So that would be root 5 multiplied by 2, or 2 root 5 will be my final answer. So this was about the operations that we cannot do with irrational numbers as far as we are considering the addition and the subtraction. Now let us see how what are the things that we need to keep into our mind when we do multiplication or division of irrational numbers. The first thing that we have is root 5. Say let's assume root 5 multiplied by root 5 will be equal to 5, and if I have 5 divided by root 5, then that would be written as root 5. Same way in division. So this was about multiplication and division of irrational numbers. These are the things that we need to consider, that these are the things that we need to keep in our mind. We would formally be looking at multiplication, addition, subtraction and division of irrational numbers in the next section. But these are the things that we need to keep in our mind before we actually go ahead and do addition, subtraction, multiplication and division. Like we wrote the rational numbers in their simplest forms, we should always write irrational numbers in their simplest forms as well. Now how can we do it? Now if I have say root of 27, then it can be written as root of 3 multiplied by 3 multiplied by 3. So this can be written as root of 3 square multiplied by 3. I can take the square out of the square root sign and write this as 3 root 3. So whenever you write root 27, it is always preferable to write it as 3 root 3, which is its simplest form. So these are the things that we needed to consider before we actually started understanding the 4 operations on rational numbers. These 4 operations are addition, subtraction, multiplication and division. Now let us go ahead with the first operation, that is addition of irrational numbers. So the first thing that we have is addition of irrational numbers. Now whenever we have to add the irrational numbers, one thing that we need to keep in our mind is the number under the sign, under the root sign, should be same first, and the power of the power of the root should also be the same. Now what do we mean by the power of the root? So if it's a square root, then we can add 2 square roots if they have same numbers under them. So I can add 2 root 3 plus 3 root 3. Since we have a root 3 here and a root 3 here, I can add or subtract them. So it's square root of 3 and square root of 3. So I would be taking it as 2 plus 3 multiplied by root 3. I've taken root 3 common outside, giving me 5 root 3. However, if one of them was a square root and the other was a cube root, it wouldn't have been possible. So I cannot add a root 3, a 2 root 3 plus 3 cube root 3. This addition is not possible under irrational numbers. This addition is possible. So whenever you add or subtract 2 rational numbers, the first thing that you need to consider is what is the number under the root sign and which root sign we are using, whether it's the square root, the cube root, or the 4th root, or the 5th root. Okay. Now, the other thing that we have is, if we consider, so this is not possible. Yeah. Now, what happens if I subtract these two? So if I subtract these two, I'll get root 2 root 3 minus 3 root 3. So again, I'll do exactly the same thing. Instead of writing 2 plus 3, I'll write 2 minus 3 times root 3, giving me a minus 1 root 3, or simply a minus root 3. So this was about addition and subtraction of rational number, addition and subtraction of irrational numbers. Now you need to keep it in mind the root, which root it is, and what is the number under the root. Okay, let's go ahead and talk about multiplication and division of irrational numbers. Let us take them one by one. So the first thing is multiplication of 2 irrational numbers. Now there are 2 ways to multiply it. If it's an irrational number with an addition sign, and if it's an irrational number without an addition sign. So let us see how we can tackle them. So if I have 3 root 6 and I multiplied by 2 root 3. The technique is pretty simple. Whatever is outside the root sign gets multiplied separately, and whatever is inside the root sign gets multiplied separately. So I can write it as 6 root 18. However, 18 I can simplify it and I can write it as 6 multiplied by, now 18 I can simplify it as 3 multiplied by 3 multiplied by 2. So here I have a 3 square, so I can take that 3 square outside the root sign, which would give me 3. So it would be 6 multiplied by 3 root 2, giving me my final answer as 18 root 2. So it's a very crucial thing that you keep it in mind. Now let us go ahead with and see what happens if it has an addition sign in them. So now we will be discussing about an irrational number which has a rational part as well, which is added to it. So say let us have 3 plus 4 root 2 and I multiplied by 4 plus 3 root, so let's have it as 3 root 3 here. Now we would be expanding it using a plus b multiplied by c plus d, which is generally written as ac plus AD plus BC plus BD. So we should get 4 different terms. This multiplies this, then this multiplies this, then this multiplies this, then this multiplies this. So here we'll get 3 multiplied by 4 plus 3 multiplied by 3 root 3 plus 4 root 2 multiplied by 4 plus 4 root 2 multiplied by 3 root 3. And then we would solve them separately, giving us 12 plus 9 root 3 plus 16 root 2 plus 12 root 6. So this would be expansion of an irrational number that is written like this. So you see, it looks pretty large and it would have various terms. Many times these terms do get cancelled out, however it is not true always. Now let us go ahead with division of rational numbers. Now let us talk about division. So say I have 3 root 5 divided by 5 root 5. In this case, now division, they can cancel each other only if they are same or they are factors of each other. So we would write it as 3 divided by 5. That would be our final answer, because this root 5 and root 5 would get cancelled out. So effectively we'll have 3 root 5 divided by 3 root 5. Since they are the same number, we can cancel them out and write it as 3 upon 5. Now what happens if I have say 4 root 6 divided by 2 root 3? In this case I'll write 4 root 6 divided by 2 root 3, which further can be written as 2 multiplied by 2 multiplied by root 3 multiplied by root 2, because root 6 is root 3 multiplied by root 2. Now I have separated them out. I'll know in a minute. So it is 2 multiplied by root 3. So you see, this root 2 would get cancelled with this root 2, this root 3 would get cancelled with this root 3, giving me the answer as 2 root 2. Now this can be done only under one specific condition, that is, whatever is under this root should be divisible by the number under this root. If it's not true, like it was, see, if it was true here, so we did it. Here the whole 6 was not divisible, however, whole 6 did not get converted into 1, it got converted into root 2, so we have kept it. This was about division of one irrational number by another irrational number, where we were just talking about a single irrational number. Now let us see what happens if we have to divide it by a number which has a sum. Now if we have to divide two numbers which are having a plus sign between them, so we have a rational part and an irrational part separated by a plus or a minus sign, then that is taught under a completely different topic called as rationalization of the denominator of an irrational number. So let us see how we would be doing it. So let us have, say, 2 plus 3 root 2 divided by 4 plus 3 root 3. Now we have to divide this number by this number. This is slightly tricky. Let's see how this works out. 2 plus 3 root 2 divided by 4 plus 3 root 3. So you see, there is an irrational number on the denominator. Now it is very crucial for you to understand that we can never have irrational numbers on the denominator. Always. So if you get an irrational number on the denominator, you have to rationalize it. The process is called as a rationalization of the denominator, and we are learning it under division of irrational numbers. So how are we going to do it? Now what would make this number rational? If I multiply the numerator and the denominator by 4 minus 3 root 3 divided by 4 minus 3 root 3. What would it do? It would make my denominator rational. How? Because then I'll have a plus b multiplied by a minus b, and it should be equal to a square minus b square. So we would be using this identity a plus b multiplied by a minus b is equal to a square minus b square. Now you see both of them are in squares, which would absolutely remove the irrational part from it. And since we are multiplying it to both the numerator and the denominator, it is not actually going to change the value of my irrational number. So let us see how we can do it. So we'd have it as 2 plus 3 root 2 multiplied by 4 minus 3 root 3, the whole thing divided by 4 square minus 3 root 3 square. Let's take it a step ahead. So it would be equal to, so first we'll have to multiply these out. So it would be 8 minus 2 3s are 6, so 6 root 3 plus 12 root 2 minus 3 3s are 9 and 6, so it would be 9 root 6 divided by 16 minus 27. Now let's go ahead with the next part that is there. So we would separate them out. So it would come to be 8 minus 6 root 3 plus 12 root 2 minus 9 root 6, the whole thing divided by minus 11. Since there is a minus sign, the final answer here would be equal to, so since I have to take the minus sign up here, I'll make it as minus 8 plus 6 root 3 plus minus 12 root 2 plus 9 root 6, and the whole thing divided by 11. So this would be my final answer. So whenever I have irrational number and there is a division of them, I would always rationalize the denominator. How would I rationalize the denominator? By multiplying it by a number which is a number minus the sign of the irrational part change. So this number that I get is called as the rationalizing factor of the number. So 4 minus 3 root 3 is the rationalizing factor of 4 plus 3 root 3. Now let's go to the last part of this topic, that is surds. So the last part that we have is surds. Surds are numbers whose powers are as a fraction. So anything that is to the power of, say, x to the power of 1 by n is called as a surd. So anything to the power of a fraction would be called as a surd or a radical. Surd is a special part of irrational numbers. So we have surds and then we have other irrational numbers like pi and e, which are constants and which have a specific value which is non-terminating, non-recurring. So majority of the irrational numbers are actually surds, but not all surds. So all surds are irrational. However, not all irrational numbers are surds. So I can have, so this can be written in the simple form as nth root of x. So I'd write it as nth root of x. So it is the nth root of x. That is, so square is the second root, cube is the third root, then we have fourth root, fifth root, so on and so forth. And all of them are going to be surds if they don't have a perfect value. Here, this n is called as the order of the surd. So the order of a square root is always 2, order of a cube root is 3, order of a fourth root is 4, fifth root is 5. So friends, that was about it. Today we covered irrational numbers and the operations on irrational numbers. If you found this video helpful, please give us a thumbs up, do share it with your friends and do subscribe to our channel. This was Dr. Rishi from the Learners Academy. Thank you.